Okay, so just deriving what we were talking about in class today. Whoops. If the momentum of a particle of mass m is gamma mu, and the net force, or Newton's second law, tells us that it is the time derivative of momentum, it is therefore ddt of gamma mu. If we are in one dimension, in 1D, in other words, we exert a force in the same direction as the motion, then we don't have to worry about directions and we can just make these magnitudes. So therefore, F net is equal to ddt of gamma mu. Now, how do we do this derivative? Gamma is time dependent and u is time dependent, m is not. So therefore, F net equals m times the quantity d gamma dt times u plus gamma times du dt. So gamma times du dt is just acceleration, but so we have to do a d gamma dt. So we need to take the derivative of gamma with respect to t, and then we can go and plug into all this. So if gamma is 1 minus u squared over c squared to the minus 1/2, right? That's just equal to square root of 1 over 1 minus u squared over c squared. Then therefore d gamma dt is equal to minus 1/2. So we pull the half down, and so we get 1 minus u squared over c squared to the 1 less power, minus 3/2, and then we have to take the derivative of the inside, which is minus 2u over c squared times du dt. So that is the correct derivative of gamma. Make sure you understand how to do derivatives. Now note that this term right here, that's just gamma cubed, right? Because gamma is 1 minus u squared over c squared to the 1 minus 1/2, and this is that raised to the third. So this is gamma cubed. So therefore, d gamma dt is equal to, let's multiply some of these things out. We've got the minus 1/2 times minus 2u over c squared. So we've got minus 1/2. I'm just making sure I didn't drop something. I feel like I did. Okay, so this is all good. So minus 1/2 times minus 2u over c squared. So the thing in yellow was gamma cubed, and we have minus 1/2 minus 2, that's just 1, so you got u over c squared, and du dt. Du dt is just the acceleration. Du dt is the magnitude of the acceleration. So that's d gamma dt. We're going to go plug that back into what was on the previous page. Let's look at the previous page. Right, so we're going to plug that in here. So let's go ahead and do that. Did I say that was du dt? That was d gamma dt. D gamma dt. So what goes with d gamma dt is gamma cubed u over c squared a, gamma cubed u over c squared a. We're left with, there's also another u, I guess I could have just squared the u, plus gamma du dt is acceleration. Okay, so we've got that, and so we can now try to simplify this. Let's factor out a gamma cubed a. Gamma cubed ma, factoring out a gamma cubed a, and we're left with u squared over c squared plus gamma. Oops, not plus gamma, sorry. I factored out a gamma cubed, so when I have the gamma here, then I factor out the gamma cubed, we're going to get 1 over gamma squared. So just rewriting on a new page, this is what I've got, and so now I've got to simplify what's in the brackets. So we've got gamma cubed, ma, u squared over c squared. 1 over gamma squared is just 1 minus, 1 minus 1 minus u squared over c squared. All right, that's 1 over gamma squared. So what does that equal? That equals gamma cubed ma. Okay, F net in one dimension, F net in Newton's second law in relativity is gamma cubed ma.